So this question changes slightly now when you see that we're doing a cross-section which is perpendicular to the y-axis. So very similar, but again, you're going to have to think about what that changes if you're doing a perpendicular to the y-axis. Okay, so see if you can set it up. This answer is not looking for a numerical value, just a proper integral. Okay, so I can see pictures are starting, so I'll catch up to you. Again, start here in my picture. It says it's going to be 2 minus x squared. So I basically only need this one portion. Let's just see here. It says in the first quadrant, so I'm only dealing with this part of the parabola, even though it does continue here. It's just this green region that I'm looking for right there. So if the cross-section perpendicular to the y-axis, so here's my cross-section, okay, it tells me that the cross-section has to go like this. So that's, well, it's more like a rectangle than a square. Let me try that again. Okay, this one will be easier to draw a square. So about like that for my cross-section. So there's a difference though, now that I'm perpendicular to the y-axis. What you have to imagine is that this object is actually, if it was 3D, it would be coming up out of my whiteboard, and the slices, right, as I take the slice, this is what it would look like if you were staring down at it. Each slice would look like this, right? So it's the slices that are going to get progressively thinner so that we end up with a true value instead of these gaps that I would have, like right here, there's a gap. So if you think about your slice is going to become infinitesimally small, but the vertical part of it does. So we know it's a dy question. Okay, so when you're going perpendicular to the y-axis, that is the same as telling you it's going to be dy, or with respect to y. So this equation here is not set up to do that. So what we have to do is rearrange a little bit so that we can see an equation for y. So this time it'll be, let's see here. So x squared is 2 minus y. X is plus or minus root 2 minus y. So if you think about the x-axis, this is the negative side, this is the positive side. So in my picture, what I want really is just this half, 2 minus y. Okay? So the square now, the problem is the same as before. The length of this piece is the square root of 2 minus y. My area function is on y, and it's going to be 2 minus y all squared. So that's not bad, it just becomes 2 minus y. Okay, so the tricky part here was to recognize that you're going with respect to y, so you have to rearrange your equation. That means here, when I look for my integral, again, if it's with respect to y, don't look here. That's not with respect to y. Now when we're slicing, our slices go like this. So we're moving vertically. We're moving from 0 up to here, which is 2. Okay? If you looked at it the wrong way, if you look at it with respect to x, you're going to be looking from here to root 2. But again, that's with respect to the wrong letter. Unfortunately, that is one of the choices there in one of the answers, or maybe a couple of the answers here. There's lots of root 2's in the answers. But again, that's just a distraction. So if it's with respect to y, it goes from 0 up to 2. So that's what my bounds are. We already said it was a square. This is the area function here. So it's going to be 2 minus y dy. So it looks like B is our choice. Okay, so the other topic that we had in this section on volumes and areas was area between curves. So this is a calculator question. It's certainly not one you'd be expected to do without a calculator. Those are some tough functions to work with. So get a good picture, find their intersections, see if you can come up with the integral that will give you the area between those two curves. I think from what I remember, that was the, oh, question, yes?
It's not the area, you notice like all the 2 parts as well, the
Well,
oh, they share the, yeah, but.
oh, it's okay? Yeah, okay. So this is the picture that hopefully you're working with, or something that looks similar. In order to integrate, I need to find out what those points are. The integral itself is not that difficult once you look at the picture. The integral is going to be the top function, which is cos x, and the bottom function, which is natural log x squared plus 1. So cos x minus natural log x squared plus 1. It's these bounds here that we need to get, which I believe if you go 0.9159, I think, just to 4 decimal places, 0.9159 on this side, and that's using your TI-83's calc and then intersect method. So from negative 0.9159 to 0.9159, and this is a calculator one that we'd certainly use. So I'll put it in and see what the calculator gives us back. Okay, so I get a picture that tells me it's about 1.1679 to 4 decimal places. Okay, so the last thing that we'll look at is related to this question is it has to do with same picture, but cross-sectional area is used again. So this time we're using that same region, except we're going to change it and see can you do the equilateral triangle type cross-section again. Okay, so you'll have to rely on some of your Math 12 skills for finding the area and the relationships in that triangle. So this is the key part that you remember here. We're trying to find the height and the base. And of course you're going to need a picture, so if I redraw it, you could use the picture you've already got, but roughly it was something like this. And the cross section I'm looking at is this equilateral triangle like that. Okay, so see if you can work out how that goes with an equilateral triangle. Okay, so if you look at your picture and you compare it to the triangle I've drawn, to me it looks like I'm getting the base here. I'm going to count this as the base of my picture, and I know that height is going to be cos x minus natural log x squared plus 1. So if I just focus on the part that we would use, say when we were doing Math 12, it's this half of the triangle when it's cut out. Okay? So if I take half of the base, it's this side here will be cos x minus natural log x squared plus 1. But I'm only using half of it. This is 60 degrees, and I would like to know what is the height of my triangle. I already have the base. If I can find the height, that means I can answer this question. So if I look at it, this is a trig ratio. The tangent of 60 degrees is equal to the opposite over the adjacent. So that's all this. Okay, so that's the relationship that tangent 60 tells me. Do you remember what tangent of 60 is as an exact value? Yeah, just root 3, right? Opposite over adjacent. This side is normally in that triangle. When we were working with it was root 3 and this side was 2. So yeah, it'd be root 3 over 2. Or sorry, just Peter. Yeah, it's supposed to be 1. See, sometimes I guess I just assume that you're right all the time. You're that good at it. So move it to the other side. That gives me an equation that says, maybe I'll put it here, h equals, when that goes up, it'll be root 3 over 2, and cos x minus natural log x squared plus 1. Okay, so now I have a height, and I have a base here. So I can come up with a formula, and again, this is not one you'd be doing on your own, you'd be using the calculator for it. So I have this area of a triangle is 1/2 base times height. So 1/2 times root 3 over 2 is 3 over 4 when I pull the constants out. And both pieces have that same equation. So I'm just going to write it one time as cos x minus minus natural log x squared plus 1, whole thing squared. And it's the same points that we had last time. So 0.9159 to 0.9159. Okay, so it just tells us to write it and not evaluate it. So this would be the answer for that question, that messy one.